Alright, ladies and gentlemen, this first video about Java arrays will be some review tips, so basically some fundamental building blocks that you will need to understand or at least consider as you build your understanding of Java arrays. Now you might not understand all of this by the time the video is done, but hearing it, making sure you take note of it, maybe question marks if something's still not clear, will be important to your overall growth and understanding of the topic, especially as we move on to the next videos. So the next videos after this will be declaring, creating, and initializing both primitive and object array types. So we'll actually code in that one. The video after that, we will traverse single and parallel arrays. And then the last video in the series will allow us to sort through arrays as well as to invoke some methods of the array class in the Java library. So here are all the criteria that we're going to discuss in this particular video. It seems like a lot, but it shouldn't be too bad. So let's go ahead and look at the first point. The use of array objects allows multiple related items to be represented using a single variable. So basically what that means is it allows us to collect data of the same type. Even though the data is different, it allows us to collect the data of the same type in one area. Some other metaphors you might think of is a toolbox. A toolbox allows us to collect tools, if we're going to be literal. A fishing tackle box allows us to collect fishing tackle. Your dresser drawers allow you to collect clothes. So it's all related data. So we're going to stay in the strictest sense here. So this harmonica is a great example. We see 10 holes, and it's going to be a little bit confusing because they're numbered 1 through 10, but we'll discuss that a little bit later. But we can see there's 10 elements here, and what this array stores is musical notes. So the data type of this array is musical notes, but the name of it is harmonica. So when I say harmonica, go to the 9th index, it will play the note at that index. We'll get into that a little bit more as we go. So next one, the size of an array is established at the time of creation and cannot be changed. Now an array list, which is not an array, can change and grow and shrink and stuff like that, but an array denoted by the square brackets that we'll see in the near future here, once it's built, it's built. And that's why a harmonica is a really great example, because this harmonica with its 10 elements cannot get any bigger or any smaller. Now, could I make a brand new harmonica with more slots? Absolutely. But this one has already been created. So it's done. It's 10 notes. There's no taking it back, or there's 10 slots. There's no taking it back. There's no making it bigger. There's no making it less without, of course, breaking it. But that's not an option in this particular case. Next note. Arrays can store either primitive data or object reference data. So basically what that means is there's different arrays for different purposes, just like when I started talking about tools. Well, a toolbox creates that. That's what that array is for. A book, which is an array, keeps an array of pages. It might be different sizes, but it keeps an array. Different musical notes are stored in different types of arrays, from saxophone array to harmonica, so forth and so on. So all these different types. So primitive types, int, which is our whole numbers, double, which is our floating type numbers with decimal points, and chars, which are our single characters. Those can be stored in arrays. We can keep multiples of those, but they can't be stored together. So I can't have an int array that also has chars, and I can't have a char array that also stores doubles. An array only holds one type of data. Also, as you can see on the right, we can do object types. String is an object type. We can tell because it's denoted by a capital S. If we were to create a class to represent students, a student class, we could also keep an array of those. Think of a line of students walking down a hallway in elementary school. You have the line leader at that first element, index 0, leading that line, and then the class of 20 kids, let's say, is that 20th element is the caboose. She's at index 19. Again, we'll understand the difference between an element and an index real soon. But so we can keep objects in there too. And again, students, that's the array. It's a student array. Therefore, it can't hold integers and students. It can't hold turtles and students. It can only hold the same data type. So let's look at our next fact that we'll need to keep in mind. When an array is created using the keyword new, all of its elements are initialized with a specific value based on the type of elements. So when we first create that array, let's say we create an integer array, we'll call it age. It'll be used to store the age of everybody listening to this video. Okay, but I haven't initialized it. I just said integer array age equals new integer array. There's 50 of us watching this video, so 50. Okay, so it'll hold 50 elements. Well, because I haven't initialized them, those integers default to 0, which really shouldn't be new to us because we already know that when we create an integer, let's say we declare an integer x, semicolon, and we printed out the value of x, well, it would print out 0 because we never said x is assigned the value of a number. So that rule holds true for doubles, which would be a default of 0.0, booleans, which are defaulted at false, and the one change up, the one trick perhaps, is object type. So if I were to create an array of students and there's a couple slots that I never filled in, well, if I went to that particular index or that element and I said, hey, what's here? The return would be null. There is nothing there. Null basically means there's no data here. All right, next point. Initializer list can be used to create and initialize arrays. Well, basically what this means is we can, if we wanted to, declare and create an array and assign all of its slots all in one line of code if we really wanted to, using something called initializer list. So we'll get into that in code. Just know that that's possible. You don't have to understand exactly how to do that at this point, but know that, hey, there is a way that we can do that. It's basically like when we create a basic variable. Again, going back to that whole int x. If I just say int x semicolon, well, that defaults to 0. But I can initialize it, not with a list, but a single value, int x equals 3. Well, now that has a value to it. So arrays aren't too different from variables in that regard. All right, so let's take a look at this next one. Square brackets in our code are used to access and modify an element in an array using an index number. So this is where it might get a little hairy and we'll get into it. But basically, in this red code, you'll see I have an array of musical notes. So that's the data that's being stored in there. The data in the array that I'm about to create holds musical notes. And then I'm going to name that array a harmonica. So now when I say, hey, harmonica, you know, we're talking about that array of musical notes. And we're also now assigning it the length of 10 musical notes. That next line, harmonica 8 equals G, means that this particular spot in the harmonica, if I were to blow into it, would produce that note. So remember back to the picture of the harmonica where it was labeled 1 through 10? Let's take a look at this. 1 would actually be index 0. 2, the second one, would actually be index 1. The third one would be referred to as index 2. The fourth element would be referred to as index 3. So if I wanted to create some code to access this particular element, which is actually the 1, 2, 3, 4, 5, 6, 7, 8, 9th element in here, I would have to refer to it as index 8, which brings us to this point. The valid index values for an array are 0 through 1, less than the number of elements in the array. So our harmonica had 10 elements in the array. So indexes are 0 through 1 less than the number of elements. So if I had 10 minus 1, that would be 9. So my indexes are 0 through 9. Alright, well that wraps up the building blocks of arrays. Hopefully you have a decent understanding. Take some notes. If you have some questions, like I'm not sure how this particularly applies, make sure you focus on that as we move into the next videos and see if you can sort of piece together an understanding of that. If not, Feel free to communicate with me, and I will do my best to help you understand it more clearly.